This is Module 10, Section 5.3. This section deals with an introduction to polynomials with terminology, degree of a polynomial, and combining like terms in a polynomial. Polynomials. To begin our discussion of polynomials, we need to introduce some concepts and terminology. A couple of these will be review from Module 6. Our first term that we're going to look at is term. A term is a constant and/or variables combined with multiplication or division. This is also referred to as a monomial, so that's what's new in this section. Term we've already looked at in Module 6. So for example, 3x is a term or a monomial. Notice that there's multiplication in there, and that's fine, that's a single term. 5 divided by y is a single term. There's no addition or subtraction. 3x squared y squared z, that's all a single term because there's multiplication in there. That's one term or one monomial. It could just be a constant by itself. There doesn't have to be a variable. -5 would also be considered a monomial or a single term. Coefficient, again from Module 6, is simply the numerical factor or the number in a term. So if we had, for example, this term, again, it's all multiplication, so it's a single term or a single monomial, the coefficient is the +2. If you had 1/2 z squared, the coefficient is the +1/2. If you had the monomial -4xy squared, -4 is your numerical coefficient. All right, now next we want to define a polynomial. A polynomial is a monomial or the sum of monomials. So now we've got perhaps a single term, but we may have more than one term. And so we're going to talk about, in general, what we're going to call those polynomials from one term on up. We already know that if you have a single term is considered a monomial. Mono means one. Two terms is referred to as a binomial. Okay, a binomial, bi means two, just like a bicycle has two wheels. A binomial has two terms. If you have a polynomial with three terms, that's a trinomial, kind of like a tricycle. Tricycle has three wheels. Trinomial has three terms. And if we get polynomials bigger than a trinomial, if we have 4 or more terms, we're just going to refer to that in general as a polynomial. We're not going to get more specific than that for 4 or more terms. We'll just call it a polynomial. All right, then we're also interested in defining the degree of a term. By definition, the degree of a single term or a single monomial is the highest variable exponent in the term. So for example, if I gave you this monomial and I said, tell me the degree, you would agree with me that that's the same as 3x to the first, and there's only one variable there, so by default that's going to have the highest degree. There is a degree of 1 attached to that x, and therefore the degree of that whole term is going to be a degree of 1, or it's said to be a first degree term or a first degree monomial. Okay? Another example, if you had -2/3 a squared. Again, we're interested in the variable piece of that term. The highest variable degree or power is 2, and therefore that's considered a second degree term or degree of 2. If you had 4y to the 5th, highest power there is 5, so that's said to be a term degree of 5 or a 5th degree monomial. And if you have simply a constant, any constant can be written as that constant times x to the 0. Now, if you think back to earlier sections, anything to the 0 is 1. So what I've actually written there when I write 8x to the 0 is really that's the same as 8 times 1, and you agree with me that that's 8. But what that does for me is I now have an exponent visible, a variable exponent. So therefore, the degree of this term is 0, or it's said to be 0 degree. Okay, so that's degree of a term or degree of a single monomial. Now let's expand that and talk about the degree of a polynomial. It turns out that the degree of an entire polynomial is the same as the highest degree term in the polynomial. So, for example, let's say you're looking at this polynomial, 5x cubed plus 2x squared minus 3x plus 5. We would call that just a general polynomial because there's 4 terms, and 4 or more terms we're just going to call a polynomial. So what we want to do is figure out what is the degree of each individual term. Okay? So we're interested in individual term degrees. So that first term is going to be third degree. We're going to use that degree symbol just like you would use if you were talking about temperature. Okay? That first term is third degree. This next term is second degree because the highest power is 2. This term right here has an understood degree of 1, so that's first degree. And here, remember, constants can be written as your constant times x to the 0, which is just 1, and so that constant is 0 degree. Now, to figure out the overall degree of the entire polynomial, the highest term degree is going to be the overall polynomial degree. You agree with me that all those terms have different degrees, the highest of which is third degree. So this is said to be a third degree polynomial because the highest term degree is 3. So let's look at another example. Let's say that you had 2x squared minus 8. Look at the individual term degrees. This particular term is second degree. Constants, remember, are 0 degree. Of the two, the highest of those is second degree, and so that is considered a second degree polynomial because that's the highest degree in the entire polynomial. All right, usually you want to write polynomials in what's called descending power order. That is, you want to write the terms in the polynomial so that the variable powers decrease as you read left to right. So for example, let's say I asked you to write the polynomial in descending power order, and the polynomial given was 5 plus 2x squared minus 3x cubed plus 4x. All right, descending power order. So if you look at the degree of each of those terms, okay, we've got 0 degree here. We've got second degree here, highest power is 2. We've got third degree here, and we've got an understood first degree here. Write the highest powered term first. Make sure you carry the sign with it. You agree with me that the largest power there is the x cubed. Okay? There is a negative 3 attached to that, so carry it with. Okay? So you've got negative 3x cubed. Next highest power is plus 2x squared. Next highest power is plus 4x to the first, or plus 4x. And last but not least is the positive 5 constant that will be tacked on to the end. Notice that the powers go 3, 2, 1, and no variable power. Now, if there's a missing integer power in the polynomial, you may be asked to rewrite the polynomial with no missing powers. To insert a missing power term, just add the missing power term with a 0 as its coefficient. For example, 5x cubed minus 4x plus 9. If you look at the powers, notice it goes from 3 to 1. Remember, this is the same as x to the 0 to 0. So you're going 3, 1, 0. in terms of integer order, you're missing a power of 2. So you can put that term in as shown here. You can put that x squared term in by putting a 0 ahead of it. And the reason for that is 0 times anything is just 0. And so really, 5x cubed plus 0x squared minus 4x plus 9 is the same as 5x cubed minus 4x plus 9, which was the original polynomial. Adding or subtracting 0 doesn't change anything. Okay, so let's practice that. Let's rewrite each polynomial in descending power order with no missing powers. Find the degree of each polynomial and determine whether it's a monomial, binomial, trinomial, or none of these. All right, so we're asked to do several things here, so I'm going to make a table to keep track. We want everything to be in descending power order. Okay, so that's the first thing we're going to do, descending power order. No missing powers, so we're going to put in 0 coefficients if we need to. Then we want to determine the degree of the polynomial. So that'll be the highest powered term will be the same as the degree of the polynomial. And we want to then label it more specifically as monomial, binomial, trinomial, or none of these. Okay, so let's start with this first term here, negative 5y squared plus 4. Notice we're going from y squared to an understood y to the 0. We're missing a y to the first term. So we've got negative 5y squared plus 0y to the first. We're putting in our missing power plus 4. We're going power-wise 2, 1, 0. Now the degree of that polynomial, the highest power in that expression is a power of 2, which means it's a second degree polynomial. And now in terms of label, what we're interested in labeling is we're interested in the label of the original polynomial before we put in any missing powers. So we want to look at the original problem here. You would agree with me that there are 2 terms there, and so that original problem was a binomial because there were 2 terms. All right, 3m minus 5m cubed minus 8. We're going to write that in descending power order. So the highest powered term is that m cubed. You want to carry the coefficient and the sign with it. So we've got negative 5m cubed. The next power in descending order should be an m squared term. We don't have that, so we're going to put it in with a coefficient of 0, 0m squared. Next in descending power should be an m to the first term. We have that. It's a positive 3m. And lastly, we've got our constant, which is the same as m to the 0, minus 8. Okay? The degree of that polynomial would be third degree, because the highest power is 3. And again, looking at the original problem, there were 1, 2, 3 terms. Remember, terms are separated by addition or subtraction. And so the original problem was a trinomial. Okay, our next one. This should be a power of 4 here. Okay. We've got negative 6x to the 4th. We don't have a power of 3, so that would be 0x cubed. We don't have an x squared, so that would be 0x squared. We do have an x to the first term. That's minus 2x, and then plus 8 as our constant at the end. Highest power there is 4, so that's a 4th degree polynomial. And looking at the original problem, there's 1, 2, 3 terms. And so again, that is originally a trinomial before we put in our placeholder missing powers. Okay, this problem here, the highest power is a y to the first, so we're going to take the coefficient in front of it. We've got negative 4y, and then the next power would be a y to the 0, which is just your constant, so that would be a plus 5. So there are no missing powers there in that series. Highest power is 1, so that's a first degree polynomial. And a first-degree polynomial had two terms in it. It's a binomial in terms of label. You may be able to simplify polynomials before working with them by combining like terms. Okay, so this isn't anything new. You know about combining like terms. To combine like terms, the variable piece has to be exactly the same, like 2x cubed and negative 8x cubed. Remember to carry the sign ahead of it, or change subtraction to adding a negative. Okay. In either case, you've got 2 minus 8, or 2 plus a negative 8. That leaves you with a negative 6. And remember, combining like terms, the variable piece just tacks along. For example, if you're taking 2 apples plus 3 apples, you've got 5 apples. The variable piece doesn't change. All right, there are no x squared terms, so we'll move on to our x to the first term. We've got a positive 3 and a positive 5. That's a total positive 8x. And then our constants, negative 8 and positive 6. That leaves us with a minus 2. This particular problem didn't ask us to put in missing powers, so we'll just leave our answer like that. Always a good idea, though, to go in descending power order if possible. Finally, if you are asked to evaluate a polynomial, simply substitute the values given into the expression and simplify. Now, you already know this. If it says evaluate, it's simply a matter of taking the number they give you, plugging it in for the variable, wherever the variable appears. Everything else stays the same. All mathematical operations stay the same. Simplify and see what you get. So if we put negative 2 in for those x's, we get 3 times x, which is negative 2 squared, minus 2 times x, which is negative 2, plus 4. Now it's an orders of operation problem, so do the exponent first. We've got 3 times negative 2 squared. Negative 2 times negative 2 is a positive 4. Minus 2 times negative 2 is negative 4. Or if you want to, you can think about that as negative 2 times negative 2. That'll end up being a positive 4, and the same thing is true here. Minus a negative is the same as adding a positive. So either way, you're going to end up adding a 4 there. And then you have that plus 4 on the end. That gives us 12 plus 4 plus 4. And working left to right, 12 plus 4 is 16. 16 plus another 4 is 20. So that brings us to the end of Module 10, Section 5.3 material. You should now complete the homework for Section 5.3 found in My Math Lab. And when you have successfully completed the homework, proceed to the video for Module 10, Section 5.4.